In this video, we're going to discuss factoring using reverse FOIL. Let's say we have the trinomial x squared plus 9x plus 20, and we want to find its factors. Now, in previous videos, we've discussed factoring using GCF, and you want to look quickly at this trinomial. Is there a GCF? And there is not. Next, we discussed the difference of two perfect squares. Is this the difference of two perfect squares? Obviously, it's not, because it has three terms. The difference of two perfect squares could only be two terms. So, we're going to have to use reverse FOIL. Reverse FOIL only works when before the x squared, we only have a 1. If we have, let's say, 2x squared plus 9x plus 20, that would not work for reverse FOIL. We're going to have to use something else. So here, this question looks like it's going to work for reverse FOIL. We want to get this trinomial back to two terms that are being multiplied. That's what factoring is. How are we going to do that? Every trinomial with an x squared, an x, and a constant is in the form of ax squared plus bx plus c. A, in this question, would be 1. A is the coefficient of the x squared term. B, in this question, would be 9, because B is the coefficient of the x term. And C is the constant. So in this question, C is 20. We want to find factors of the C term, factors of 20, that add up to 9. So let's look at the factors of 20. We have 1 and 20, those are factors of 20. We have 2 and 10, are factors of 20. We have 4 and 5, are factors of 20. We want to find, of these terms, which one adds up to our B term. Which one adds up to 9? Do 1 and 20, do those add up to 9? No. 20 and 1 add up to 21. 2 and 10, do those add up to 9? No. 2 and 10 add up to 12. 4 and 5, do those add up to 9? Yes, they do. 4 plus 5 is 9. So these are the terms that we want. So whenever we do reverse FOIL, our first term is going to be an x, and our first term is going to be x for both of them. As long as we have an x squared, our first term is going to be x for both of the terms. Then, since this is a positive 4, this is a positive 5, all we're going to do is plug that in right over here. Plus 4 plus 5. And these are our two factors. Let's see if we got it right. We can use FOIL to FOIL our two binomials, see if we get back to our original trinomial. So we're going to do first, x times x is x squared. Outer, x times 5 is 5x. Inner, x times 4 is 4x. And last, 5 times 4 is 20. So let's combine like terms. X squared, there's no like term for x squared. Plus 5x and plus 4x, those are like terms, we can combine them to 9x. And plus 20, there's no like terms, that's just plus 20. Is that our original equation? Since it is, the answer is correct. Let's try another example. Let's say we have x squared plus 10x plus 16, and we want to factor this. The first thing we always want to do when factoring is check, is there a GCF? In this question, there's no GCF. The next thing we want to do is check, is this the difference of two perfect squares? Obviously it's not, because we have three terms, not two terms. So we're going to try to use reverse FOIL. Can we use reverse FOIL? Yes, we can, because our A term, the coefficient of x squared, is 1. The first thing we want to do is see, can we find factors of the C term in this case is 16, Can we find factors of 16 that add up to our b term, which is 10? Let's find factors of 16. Factors of 16 are 1 and 16, 2 and 8, and 4 and 4. Do any of these add up to 10? Yes. 2 plus 8 is 10. So those are the ones that we want. Always when we're doing reverse FOIL, if we have an x squared, our first term is going to be x, and our first term would be x for both of the binomials. And then we have a positive 2 and a positive 8. These are our two terms, so we have plus 2 plus 8, and this would be our answer. Of course, we always want to check back by using FOIL to make sure that our new equation, x plus 2 times x plus 8, would be equal to our original expression. So first, x times x is x squared. Outer, x times 8 is 8x. Inner, 2 times x is 2x. And last, 2 times 8 is 16. Combine like terms, x squared plus 8 and 2x are like 8x and 2x are like terms, so plus 10x plus 16. This is our original question, so the answer is correct. Let's do another problem. Let's say we have x squared minus 9x plus 18. We want to factor this. The first thing we always want to do when factoring, is there GCF? No, there's not. Is this the difference of two perfect squares? No, it's not. So we're going to use reverse FOIL, which we can do because a in this case is 1. We want to find factors of 18, factors of the c term, that add up to term. So factors of 18 are 1 and 18, 2 and 9, 3 and 6. Do any of these factors add to negative 9? We have to remember this is a negative 9. 18 plus 1 is 19. 2 plus 9 is 11. 6 plus 3 is positive 9. Oh no, we have no factors of 18 that add up to negative 9. So let's see. Maybe there are more factors of 18 that we didn't realize. What if we would do negative 1 times negative 18? Are those factors of 18 also? And yes, they are, because negative 1 times negative 18 is also positive 18. How about negative 2 times negative 9? Those are also factors of 18 because negative 2 times negative 9 is also positive 18. How about negative 3 and negative 6? Because negative 3 times negative 6 is also positive 18. Do any of these new factors add up to negative 9? Negative 18 plus negative 1 is negative 19. That's not the answer. Negative 2 plus negative 9 is negative 11. Negative 3 plus negative 6 is negative 9. That's what we wanted. So those are the ones we're going to use. We always have, whenever we have ax squared, our first terms of the two factors are going to be x and x. Then we just plug in the two factors that we found, so minus 3 and minus 6. Of course, you would want to FOIL back to make sure that when you FOIL, you get back to this original equation. We're not going to do it here just because we've done enough practice with FOILing, and you can do it on your own if you want to check to make sure it's right. Let's try another example. Let's say we have x squared minus 10x plus 16, and we want to factor this. Can we use GCF? No. Can we use the difference of two perfect squares? No. So we're going to have to use reverse FOIL. Can we use reverse FOIL? Yes, because a, the coefficient of x squared, is 1. The first thing we want to do is find factors of the c term. The c term in this case is 16. We want to find factors of 16 that add up to the b term, which in this case is negative 10. We don't want to forget about that negative. It's very important. Factors of 16 are 1 and 16, 2 and 8, 4 and 4. Do any of these add up to negative 10? 1 plus 16 is 17. 2 plus 8 is positive 10. 4 plus 4 is 8. So none of these factors add up to negative 10. Obviously, we have to see, are we missing any factors? And we are. We're missing -1 and -16, -2 and -8, -4 and -4, because -1 times -16 is +16, -2 times -8 is +16, and -4 times -4 is also +16. So these are also factors of +16. Do any of these new terms add up to -10? And of course, there is one. -2 and -8. -2 plus -8 is -10. So let's factor the trinomial. The first terms of the two binomials are going to be x, as usual. And then we just plug in what we found, -2 and -8. You would, of course, want to FOIL this out to make sure it is correct. We're not going to do it now. We've done enough practice with FOILing. But you can try it out to make sure that we got it right. Let's do another example. We want to factor x squared plus 2x minus 8. How would we do that? We want to find factors of c that add up to b. C in this case is -8. We want factors of -8 that add up to b, which is +2. So we have factors of -8 are 1 and -8, -1 and +8, 2 and -4, -2 and +4, and that's it. Which one of these add up to +2? -8 plus 1 is -7. -1 plus 8 is 7. -4 plus 2 is -2. -2 plus 4 is +2. So these will be the two numbers that we're plugging in. So as usual, since we have an x squared as our first term, we're going to have x and x as the first term in the binomials, and we just plug in what we found, -2 and +4. This is the answer. Of course, you would probably want to FOIL back. If this was on a test, you'd want to FOIL back to make sure we got it correct. In this case, it is correct. Let's do another example. Let's say we wanted to factor x squared plus 7x minus 8. To do that, we would need to find factors of -8 that add up to +7. Factors of -8 are +1 and -8, -1 and +8, 2 and -4, and -2 and +4. Now, which one of these adds up to +7? -1 and +8. So, in factored form, this would look like x and x, and we just add the -1 and the +8. You would, of course, want to FOIL back to make sure we got it right. Let's do two more examples. Let's say we had x squared minus x minus 6, and we wanted to factor this. We need to find factors of -6 that add up. There's no coefficient. We just assume that's a 1, or in this case, it would be a -1. We need to find factors of -6 that add up to -1. Factors of -6 are 1 and -6, -1 and +6, -2 and +3, -3 and +2. Which one of these adds up to -1? -3 and +2. So, in factored form, x squared minus 1x or minus x minus 6 is equal to x minus 3 and x plus 2. To check it, you can always FOIL back. Let's do one last example. X squared minus 5x minus 6. We need to find factors of -6 that add up to -5. Factors of -6 are +1 and -6, -1 and +6, 2 and -3, -2 and +3. Which one of these adds up to -5? -6 and +1. So we can rewrite this as x, x plus 1, x minus 6. And you could always FOIL back to make sure it is correct.